Good morning, dear students. Today we will continue with our chapter 2 units and measurement in physics. And under this section, we have to discuss about the second application of dimensional analysis. That is, under this section, we will discuss how to check the dimensional consistency of physical equations. If you are provided with some equations, some mathematical expression, you can check whether the given equation or physical relation is dimensionally correct or not. So today our topic is checking the dimensional consistency of equations. So using dimensions, we are able to check whether a given physical equation is dimensionally correct or not. We are talking about dimensional consistency of physical equation. It is we will check that it is dimensionally correct or not. Okay, for this purpose we make use of dimensions, and under dimensions we have learnt about principle of homogeneity of dimensions. So there is a wide scope and use of this principle in dimensional analysis. According to the principle of homogeneity of dimensions, it states that a physical equation will be dimensionally correct. Dear students, you have to remember this point. You have to note this point. A physical equation will be dimensionally correct if the dimensions of all the terms occurring on both sides of the equation are the same. For example, if you are given the formula S equals to ut plus half at square, there is single term in the LHS, but there are two terms on the RHS. So if S has the same dimension as that of ut and as that of half at square, all the three will have the same dimensions, then we can say that the given relation is dimensionally correct or dimensionally consistent. This principle is based on the fact. This principle, that means principle of homogeneity, is based on the fact that only the physical quantities of the same kind can be added, subtracted, or compared. As you have learnt in mathematics, like terms only can be added or subtracted. In the similar manner, in the same sense, in physics, only the physical quantities of same kind can be added, subtracted, or compared. Compared means equality holds. Okay, dear students, let's proceed. For example, velocity can be added to velocity but not to force, because force is not similar to velocity. Velocity is similar to velocity, so you can add velocity with velocity but not with force. Next, if the dimensions of all the terms on the two sides of physical equation are same, then the equation is said to be dimensionally correct. हमने ये डिस्कस कर चुके हैं, हम इसके बारे में डिस्कस किया हमने. तो the dimensions of physical quantities, if the dimensions of each term which is involved in a physical relation is the same, in that case you can say that the given physical formula is dimensionally correct. Now, for example, let us take an example. Let us check whether the following equation of motion is dimensionally correct or not, जो हमने लास्ट अभी एग्जाम्पल दिया. S equals to ut plus half at square. This is second equation of motion, and we have to check whether this is correct or not. So looking at the LHS, this is displacement, and displacement has dimension L, and RHS have two terms, ut and half at square. So we will check the dimension of ut. Ut means u means velocity, so lt minus 1, t to the power minus 1, and t is time, so into t, this will give you L. And further, half at square, again the second term of the RHS, half at square. Half is constant, no dimension, it is dimensionless. The dimension of A is L t to the power minus 2, because this is acceleration, rate of change of velocity, and t square means t square, time square, and this will be cancelled out, so we will left with L. Thus the dimension of each term in the LHS and each term in the RHS are same, hence the given physical equation is dimensionally consistent or dimensionally correct. Let us take a question. Question number 1 as an example. Check the dimensional consistency of following equations. It has been given lambda is equals to h by mv. H is Planck's constant here, m is mass of electron, and v is the velocity. So velocity of electron. So, and the second equation has been given for expression is for escape velocity. Escape velocity is equals to square root 2 gm upon r, under root 2 gm upon r, where g is gravitational constant, m is mass of earth, and r is radius of earth. You can easily do it, dear students. Let's see how. Lambda is equals to h by mv. H is Planck's constant, and the dimension for Planck's constant is ml2 t minus 2. ml2 t minus 2. You can calculate it from एनर्जी इज इक्वल्स टू एच न्यू. मैंने पढ़ाया आप लोगों को एच न्यू, प्लैंक्स हाइपोथेसिस. सो पुटिंग द वैल्यू ऑफ एच हियर and mv, mass m, and v is velocity lt minus 1, and on solving you will get L. Next, and in the LHS there is wavelength. Wavelength means L. So LHS and RHS have the same dimensions for each term, and that's why the given formula is dimensionally correct. Next one is for escape velocity. The expression is v is equals to square root under 2 gm upon r. So velocity is lt minus 1 in the LHS, and in RHS square root of 2 gm by r. 2 is constant, that is dimensionless, and the value, the dimensions for g is, you can find it, dimensions of g is, I expect all of you that you must know the dimension of capital G. This is mlt minus 2 L square divided by m square. How this can be calculated? F is equals to z m1 m2 upon r square. So G equals to fr square divided by m1 m2. From this we have substituted value here. This is the value mlt minus 2 is for force, L square is for distance ka square, and m into m for m1 into m2. And look here, m, for m there is m, and for radius there is L, and whole square root here, and after solving you will get L square t to the power minus 2, and removing the square root you will finally get L t to the power minus 1, and hence the dimension of LHS and RHS are the same. So the given physical formula is dimensionally consistent. Next question, similar question is there. Check whether the following equation is dimensionally correct. Half mv square equals to mgs. This is from your NCERT textbook. So LHS, in the LHS we have half mv square. Half mv square, half is dimensionless, m for m mass, and v square lt to the power minus 1 whole square. So lt to the velocity v is equals to lt to the power minus 1 meter per second, dear students. So we will get mla square t minus 2, and in the RHS there is mgh. M is for m, g is lt to the power minus 2, and h have the dimension of length. So the formula becomes ml square t minus 2. The expression for dimension is ml square t minus 2 in the RHS, and hence we see that the dimensions of LHS and RHS are the same here for each term, and that's why the given equation is dimensionally correct. Let's see question number 3. Check by the method of dimensions whether the following equations are correct. The first question is E equals to mc square. This is Einstein's mass energy equivalence relation. So energy equals to mc square. E is energy, m is mass, and c is speed of light. So energy has the dimension ml square t minus 2, and RHS, in the RHS there is mc square, m is for mass, and c is the velocity here, L t to the power minus 1 whole square, which will give you ml square t to the power minus 2 on opening the bracket. The dimension of each term of RHS is same as the dimension of each term of LHS. Both are same, so the given formula is dimensionally correct. Next is time period, 2 pi root under L upon G, where T is time period, L is equals to length of string, G is equals to acceleration due to gravity. In the LHS we have time period, so T is for T, the dimension of time period is T, and in the right hand side 2 pi is constant, which is dimensionless, so we take square root and L for length, and G is acceleration due to gravity, part of acceleration, and acceleration has the dimension T, L to the power minus 2, so in the denominator you have to write L to the power minus 2. L cancel out, and here we get T square under root, which will give you T. So we see that the LHS dimension have both the dimensions of LHS and RHS are equal or same, hence the given relation is dimensionally correct. The third is the velocity. Velocity of sound is given by, or speed of sound is given by, square root pressure divided by density. Here is pressure divided by density, under root pressure by density is the speed of sound. The expression has been given. We have to check whether it is dimensionally correct or not. In the LHS we have been given velocity, so Lt to the power minus 1, and RHS this is root under P by rho, so P is force by area, so mlt minus 2 divided by area L square whole divided by density. Density is kg meter cube, kg per meter cube, so m divided by L cube is here, m divided by L cube for density. So on dividing and simplifying within the square root, you will get L square t to the power minus 2 under root. So finally we get L t to the power minus 1 while after removing the square root. Hence we see that the dimension of each term in the LHS is equal to the dimension of each term in RHS, so the given physical equation is dimensionally correct. Okay dear students, I expect all of you are getting it clearly. Now fourth question is for frequency. This is frequency dear students. Frequency of pendulum is equals to 1 by 2L square root T upon M, where nu equals to frequency of vibration, L equals to length of string, and T equals to tension in the string, M equals to mass per unit length. Mass per unit length means mass divided by length. Mass divided by length. Mass per unit length means mass divided by length. Let us see dear students, in the LHS there is frequency. Frequency has dimension T to the power minus 1, and in RHS we have been given 1 upon 2L root under T upon M. So this is 1 by L, because 2 is dimensionless, into under root T is tension here. Dear students, T is tension. Tension is a type of force, so it is mlt minus 2, and M is mass per unit length, so M divided by L. M is mass per unit length, so M mass divided by length, so M divided by L. After simplification you will get like this, and the final expression comes out to be T to the power minus 1. T to the power minus 1 dear students. And in this way we see that the dimensions of LHS and dimensions of RHS are the same, hence the given physical relation is dimensionally correct. Okay dear students, this is dimensionally correct. Next, question number 4. By the methods of dimensions, test the accuracy of the equation. This is delta. Delta means depression here in this particular question. Depression in the rod M equals to mgl square upon 4 bd square y, where BD square Y or gamma you can say, where delta is the depression produced in the middle of the bar of length L, breadth B and depth D when it is loaded in the middle with mass M. Y is the Young's modulus of the material of the bar. Suppose a bar is like this, and some load is put here, so it will bend and goes down. So this is depression, this part is depression here. Okay, so we have to check the dimensional accuracy of the relation delta is equals to mgl square divided by 4bd square gamma. Let's see. Depression means changing length, so depression is L and mg is, look at this figure, right hand side, on the right hand side we have been given mgl square divided by 4bd square y, where y is equals to Young's modulus. I have told you Young's modulus or any modulus have the dimension of stress. So look here, m is for m, g is acceleration due to gravity, so lt to the power minus 2, and l is length square, 4 is dimensionless, b is breadth so length, and d square is the type of length because depth ka square, so L square into Young's modulus have the dimension ml minus 1 t to the power minus 2, same as power or stress, same as power or stress. So this is ml minus 1 t minus 1. On simplifying you will get L. Hence we see that the dimension of LHS is equal to the dimension of RHS. The given relation is dimensionally accurate or dimensionally correct. Next question is, find the dimensions of A divided by B in the equation F is equals to A root under X minus BT square, where F is force, X is distance and T is time. Dear students, you are given an expression and you have to first find the dimensions of A and B, then you have to find A divided by B. Here, since there are two terms on the RHS, two terms are on the RHS operated by minus sign, so these two terms must be equal to force because two similar like terms can be operated. So A root X represent a force and BT square also represent a force. With using this concept we can find the dimensions of A and B. Let us proceed. A root X is equals to F. X is length given in the question, so root under L is equals to mlt minus 2. Taking under root right side on the RHS, it will go to the denominator, mlt minus 2 divided by L to the power half. This will give you ml half L to the power half t to the power minus 2, and bt square is also force, t is time, so the dimension of B into t square equals to dimension of force mlt to the power minus 2. Hence the dimension of B is found to be mlt to the power minus 4 on solving. Thus the dimension of A divided by B is ml half L to the power half t to the power minus 2 divided by ml t to the power minus 4, and cancel out, so m to the power 0, L to the power 1 in denominator and L to the power half in the numerator, so L to the power minus half, and t to the power minus 4 when goes to numerator becomes plus 4, so t square. The final expression dimension for A by B is m0 L to the power minus 1 by 2 and t to the power 2. Next question is, find the dimensions of A into B in the relation power is equals to B minus X square divided by AT, where P is equals to power, X is distance and T is time. So dear students, the given relation is P is equals to B minus X square whole divided by AT. So on base separation B by AT minus X square by AT, we can write like this. So this is also power and this is also power. You can use this concept in the similar way. So here First of all, you can see here b minus x square. That means x square is subtracted from b. So b has same dimension as that of x, and x is length as given in the question. So dimension of b is x square. So L square, and b by at will have same dimension as power because this is term related to power. Hence b by at will have the dimension of power, and it is given by ml 2t minus 3. Power is work by time, dear students. You can find like this: ml2 t to the power minus 3. B is L square as we have calculated here, and a has dimension we have to find, and time for t. Thus, the dimension of A is found to be m to the power minus 1, L to the power 0, and T to the power 2. So, A into B, after substituting both the dimensions for A and B, you will get m to the power minus 1, L square, T square. Next, the van der Waals equation for the gas. This is modified form of gas equation, PV equals to nRT. So, P plus a by v square into v minus b equals to RT, where R is gas constant, T is temperature, P is pressure, V is volume, and you have to find the dimensions and SI units of A and B. So dear students, very easy question is there. A by V square will have the dimensions of pressure, and B will have the dimension of volume. So dimensions of a by v square is related to p, added to p. So a by v square equals to p. We can easily write a divided by L cube, because L cube is the volume dimension for volume, whole square equals to the volume. The dimensions for pressure is ml minus 1 t to the power minus 2. We have seen it earlier. So the dimension of A is found to be ml to the power 5 t to the power minus 2 on simplification, dear students. Next, the SI unit will be, for m it is kg, and for L it is meter to the power 5, and t to the power minus 2 can be written as second to the power minus 2. And in this way, B is subtracted from volume. As we have seen, the expression is V minus B. So V is subtracted from B is subtracted from volume, so it will be similar to the volume. Hence its dimension formula will be L cube, and the SI unit will be m to the power 3. Now I am providing you with some problems for practice. You have to attempt hard as far as possible to solve all these questions in your copy, and if there any query exists, I am always with you. You can contact me on WhatsApp or school science group. I will certainly help you within the prescribed time. These are the questions you have to do. I am providing you with the PDF soft copy of the today's class taken by me on all the topics we have done today. Okay, dear students, hope you will understand my facts and you are getting all my points whatever I am giving you in physics. So you all have to do homeworks and assignments in the prescribed time. I expect all of you to perform better. Have a good day. Okay, dear students, thank you.